Okay, this is a quick test blade to see exactly how thin I can take 5160 with my heat treat down before I start getting edge damage. This is a blade from the last run of choppers that warped excessively, so I decided not to sell it. I was gonna see if I couldn't turn it into a shorter blade or salvage it, and then I thought, well, you know, I just need to do a little bit of testing with it. So I ground it extremely thin, and frankly I'm not really expecting it to survive this. Anyway, the specs are it's 5160 from Jantz, I believe, 21 inches overall length, 14-inch blade, 1 15/16 inch wide. The spine measurement here the measurements here in the sweet spot are 235 thousandths at the spine, 40 thousandths measured a 1/4 inch back from the edge, and 10 thousandths of an inch at the shoulder of the edge where the sharpening marks end and it goes into the main bevel. A new file will cut it with considerable force. I sharpened it on a Smith's 325 grit diamond hone, and it did pass the brass rod test. So now I'm going to try it out on some pretty old 2x6s. I see one spot where the edge looks to be bent out a little bit, but I can't really tell. It could be the way that the light is reflecting off of it. Yep, it's definitely starting to ripple a little bit there in the sweet spot. I don't know if you can see that or not. So let's see if, oh, there's a good knot right there. Yep, there we go. Like I said, I didn't expect this blade, or this thin of a grind, to survive, and I guess I was right. It looks to me like the edge is being torn out. The edge did survive a flex test over a brass rod. It flexed and then sprang right back, but This portion right here looks chipped, but these portions look like they're torn. Maybe since we're destroyed it already, let's chop down in this spot a little bit for a while. Oh. There's a piece of the edge. See how it's all curled up? If the blade was too hard, I would expect that to just chip out, and they'd be in little bitty pieces all over the place. But for it to be curled up like that kind of tells me that the heat treat was about right, but it's just too much force for that geometry. I don't know, I don't want to hit the pieces of metal in there. There's a... Now we'll go through this spot, and then if it's okay, we'll hit this knot right here. There's a small knot right here, so we'll test it out. Yeah, you can start to see that edge rippling a little bit. There's another knot right here. Yep, that cracked it. You can see here the edge started rippling, but it never did chip out. And then you can see a crack here, and then another crack here. But that crack is going in and the edge is still holding together. Maybe we'll try parts of the edge on, I've got a couple of pieces of an old cedar fence I torn down. Here's one. just with the tip portion where it hadn't been damaged yet. And up here next to the ricasso. Oh, that finished tearing that chip out. This edge is really nice and thin, so I should be able to grind this back to the depth of the chip and then put another edge on it, and that should be just about perfect for that thickness, with that heat treat, with this steel, and the amount of force that I was putting behind it. Maybe even a little bit thinner than that. But now I know that with the geometry with 5160, with my heat treat, which is triple quench, and a blade that's almost 2 inches wide, starts off at 235 thousandths at the spine, 40 thousandths a quarter inch back from the edge, and a 10 thousandths edge, that is a little bit too thin. That's it for today.